Hello all, welcome to our channel. So I hope you all are doing good. Today we are back with another video, and in this video I am going to do the numerical questions, the exercise questions under the chapter motion class 9 in CRT. Okay, in the previous video we discussed the concepts of motion, and so today I thought we will do some numericals because numericals will strengthen our idea of the concepts. Okay, so let's get into them. The first question: an athlete completes one round of a circular track of diameter 200 meters in 40 seconds. What will be the distance covered and the displacement at the end of 2 minutes 20 seconds? So in this question they have asked us to calculate the distance and displacement. So there is a circular track. Okay. And it's given that the diameter of the circular track is 200 meters. So an athlete, let's say an athlete starts his journey from here and he completes one round in, he or she completes one round in 40 seconds. So after 2 minutes 20 seconds, what will be the distance covered by him and what will be the displacement covered by him? So let me write down the details. Time taken for one round is equal to 40 seconds. Okay. So after 2 minutes 20 seconds, so time of journey, time t is equal to 2 minutes 20 seconds, which can be written as 140 seconds, isn't it? So after 140 seconds, what will be the position? First we need to find the position of the athlete, and then we will have to find the distance and displacement covered. Okay. So actually 140 seconds, we know that 40 seconds is the time the athlete takes to cover one round. So in 20 seconds, he will complete half a round, isn't it? So 2 minutes 20 seconds means a total of 140 seconds. So he starts from here, 40 second one round, 80 second second round, 120 second third round, and then after 120 he has 20 more seconds. So after 120, by 140 he will reach here. So this is his initial point A, and this is his final point B. Okay, so so in total he is completing 3.5 rounds. Okay, 3.5 rounds. So in total he is completing 3.5 rounds around the track. Now to calculate the distance covered, we know that one round corresponds to 2 pi r, isn't it? Distance. One round is 2 pi r. So 2 into pi is 22 by 7, isn't it? And what is the radius of the track? Radius of the track is given to be 100 meters, 200 by 2. So that's the distance that the athlete covers when he completes one round. But in total he is completing 3.5 rounds, isn't it? So that means we need to multiply 3.5 with the perimeter, the circumference of the circle. So multiplied by 7 by 2. The 7 get cancelled, 2 gets cancelled. So the answer is 2200 meters. So that's the total distance that the athlete covers. Don't forget, write the unit. Unit is extremely important. Now, what about the displacement? As we can clearly see, the A is the initial point and B is the final point, and displacement is defined as the distance between the initial and the final point, isn't it? So how much is that? It's simply 200 meters. So displacement is equal to 200 meters. So that's about the first question. It was an easy question. I hope you all understood it. If you have any doubts, post it in the comments. Now let's go to the second question. Okay. So the second question is: Joseph jogs from one end A to another end B of a straight 300-meter road in 2 minutes 30 seconds, and then turns around and jogs 100 meters back to point C in another 1 minute. What are Joseph's average speed and velocities in jogging A from A to B, B from A to C? So it's a big question. Okay, let's read it by parts. So there is a straight 300-meter road, okay, whose one end is A and the other end is B. So let's this be the track A, B. The total distance is 300 meter. Okay. So Joseph moves from A to B, the 300 meters in 2 minutes 30 seconds. Okay. So TAB is equal to 2.5 minutes. I will write 2.5 minutes. Okay, 2 minutes 30 seconds was the time given. And then turns around and jogs 100 meter back to point C in another 1 minute. So from here he turns back and jogs 100 meters. So that means this point. So this point is given as C. Okay, so this distance is 100 meters. Okay, so that's his journey. He goes from A to B, 300 meters, then comes back from B to C, which is 100 meters. And the time for B to C motion is given to be 1 minute. Okay, TBC is equal to 1 minute. Now what? What are Joseph's average speeds and velocities in jogging A from A to B and B from A to C? So we need to calculate both average speed as well as average velocities in two cases from A to B. B is from A to C. Okay. Okay. In both these cases, we need to calculate the average speed as well as the average velocity. So in A to B motion, we need to calculate average speed. So what is the equation for average speed? V average speed. Okay. V average is total distance by total time, isn't it? So what is the total distance he covers from A to B? Is 300 meters. Okay. And what is the total time that he takes? The total time that he takes is 2.5 minutes, which would be 120 plus 30, 150 seconds. So that would be 2 meters per second. This is the average speed. Now we need to calculate the average velocity. Velocity. Sorry. These both are different. This is average speed. So velocity, average velocity is simply total displacement by, or the displacement by total time taken. So again here, what the displacement is the same as the distance. So average velocity will also be equal to, and the time taken is also the same. So that means since the displacement in A to B motion is same as the distance covered, here the average velocity will also be equal to 2 meters per second. Okay, so I guess that's clear for all. Now let's consider A to C motion. This is more important. In A to C motion, he has covered a total distance. Let's be average. Okay, speed. In A to C motion, he has covered 300 meters and plus 100 meters. So that's a total of 400 meters. The total distance covered is 400 meters. And what is the total time taken? Total time taken is 2.5 plus 1 minute. So that's 3.5 minutes. So that's 150 seconds plus 60 seconds. So in total, 210 seconds. Okay. So if you simplify, you will get 40 by 21 meter per second. So that would be like around what? 1.9 or something. 1.9 meter per second. Okay. Now, in the next one, we have to calculate the average velocity. Which is displacement by time. So now the initial point is A and the final point is B. So this distance AC, what it will be 200 meters. So the displacement in this case in A to C motion will be 200 meters. And the time taken will be in total the same amount of total time, that is 210 seconds. So that would be 200 meters divided by 210 seconds. That's like 20 by 21. Okay, so this would be around 0.95 or 9 something meter per second. So these are the average speeds and velocities in both the cases. I guess this question is also clear to all. So we got the average speed and velocity, and I guess it's clear. Okay, now let's move to the third question. Okay. Third question. Abdul, while traveling to school, computes the average speed for his trip to be 20 km per hour. On his return trip along the same route, there is less traffic and the average speed is 30 km per hour. What is the average speed for Abdul's trip? Okay. So this is actually a trick question. So it's given that. Okay. Let's consider this to be school and this to be home. So we have Abdul who is traveling from his home to school. Okay, and when he traveled from his home to school, the average speed was 20 km per hour. But when he was returning in the evening, he chose the same route. That means he went through the same path. But this time traffic was less and hence his speed was faster. His average speed was 30 km per hour. Now the question is, if you consider this whole motion, that is from home to school and then school to home, if you consider this together, then what would be the average speed of Abdul? Okay, so from, let's write V average. Sorry, average from home to school going to be 20 km per hour. Okay, and V average from school to home is given to be 30 km per hour. So what would be the average speed of Abdul? From these two values, we feel like the obvious answer is the average of these two, that is 25 km per hour. But that's actually a wrong answer. So here we have to be a little bit more cautious. Okay, so what do they say to calculate the average speed? So it's very simple. Average. What is the equation for average speed? Total distance by total time. Isn't it? This is a very important equation. It seems like a very simple equation that we don't have to remember. It's like obvious. But if you forget, if you don't apply this equation, you will feel like the answer will be correct, but it would be actually wrong. Okay. So let me consider this total distance to be x. Okay, this total distance is x, the distance from home to school. So now if we are considering both the motions, that is from home to school and then back from school to home, so the total distance he covers will be equal to 2x, isn't it? And the total time that he takes, let the time for home to school motion be t hs and the time for school to home motion be t sh. Okay, so now we will resubstitute this. We know THS, that is from home to school. What is the time for going from home to school? Time is like, we know speed is distance by time. So that means time will be distance by speed. So the distance traveled is x, isn't it? And what is the speed? Speed was 20 km per hour. Okay. Now for the time taken for school to home, when he is traveling from school to home, the distance traveled is again the same, x, but the speed was 30. Since time is distance by speed, the time for school to home motion is x by 30. So these are both the times in terms of distance. So now we will substitute these values in this equation. So we will get 2x by x by 20 plus x by 30. So the x gets cancelled. So we can take x common from these two and the x will get cancelled with the x in the numerator. So the answer would be 2 by 1 by 20 plus 1 by 30, isn't it? So that would be 2 by 20 plus 30 divided by 20 into 30, isn't it? So that would be 2 into 20 into 30 divided by 50, isn't it? So we can cancel 1 0 with another 0, 5 with 24. So 2 into 4, 8 multiplied by 3 would be 24. I hope I didn't make any mistakes. 0 0 cancel. Then 5 are 4 times in 20. 4 into 2, 8 multiplied by 3 is 24. So the average speed of Abdul, V average, is 24 km per hour. Okay. So I said that was an interesting question. I hope you all understood this. So now let's move to the next question. Okay, so let's move to the next question. Fourth question. A motorboat starts from rest on a lake, accelerates in a straight line at a constant rate of 3 meter per second square for 8 seconds. How far does the boat travel during this time? Okay, so they are asking us to calculate the distance travel. So there is a lake and there is a boat. Okay, and the boat is moving in a straight line. Okay, and it's given that the boat starts from rest. So that means if it's given that the object starts from rest, then that means the initial speed is equal to 0. The initial speed or velocity is equal to 0 meter per second. So that's the first information that we have. Next information is that it accelerates. Okay, at a constant rate. So it's a uniform accelerated motion. And it's given that the acceleration is 3 meter per second square. So A is equal to 3 meter per second square. Okay. And given that the time of the motion is for 8 seconds, given that t is equal to 8 seconds. Okay, so we have all the information. Now they are asking us to calculate how far does the boat travel during the time. So they are asking us to calculate how far does the boat travel. So in this question it's a direct substitution question of the equation of motion, like the motion equation that we have learned three equations. V is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to 2as. So I guess the second equation might work here. S is equal to ut plus half at square, isn't it? Yeah, this equation is sufficient. So that would be 0 times 8 plus half into, what is the acceleration? 3. And what is the time? Time is 8. So 8 square. So that would be 3 by 2 into 64. 2 cancels, that would be 32. So in total the answer would be 96 meters. So that was a very easy question. So the distance that the boat travels in 8 seconds, if it is going with an accelerator, if it's undergoing an acceleration of 3 meters per second square and starting from rest, would be 96 meters. Now let's move to the okay. 6 more questions remaining. Okay. And we will discuss it in the second part. Okay. So for now, we will end this video here. I hope you enjoyed this video and learned to solve a few questions from motion chapter. See you.